Okay, so I've kind of explained to you how they went from, abiotic to biotic. Is there any way to prove that's how it happened on Earth? No, there's really no way. But that's the way it happened in a lab, and so they can. That's the best explanation they have. But where did it occur? Is the next question. Okay, so now we know that origins of life actually happened. Well, how did it happen? I just explained it. Well, where did it happen? Well, it had to have happened probably in shallow water and the moist sediment, or in areas that have lots and lots of energy. So that would be most. We know now that prokaryotes started in water. Okay, everything was marine back then, and then they've slowly started to colonize land. So it had to have been in some sort of environment that has a lot of water in it. But we don't know that it's in shallow water or moist sediment. It's probably going to be there. But then you also have to take into account that we see a lot of prokaryotes that are very, very ancient that live in the deep sea vents and in volcanoes. And that has the possibility of being one of the main places where where the origin of life does occur, because of all the energy that is needed to catalyze these polymerizations. It's so high, it's abundant right there in the deep sea vents and the volcanoes. That's a lot of thermal energy to be able to use to for polymerization. And also, these are places that are rich in iron and sulfur, which are common sources for energy for many of those archaeans. All right, we know that there are such things as chemoautotrophs that use energy from the sun, but they also get their chemical energy from things other than oxygen to fuel their electron transport chains, like iron in the sulfur springs, and I'm sorry, sulfur in the sulfur springs, and iron in the deep sea vents. So it makes a lot of sense when we think about it logically that there's water, there's chemicals, there's inorganic compounds, and there's energy abundant right there in the deep sea vents. So it makes sense that there would be life that starts to accumulate in those areas. Now, the last thing in this chapter that they go over is what we decide is a major lineage of life. Okay, so I don't know that you guys are old enough for this, but back when I was in high school, they categorized all prokaryotes in the kingdom Monera. It was a 5-kingdom system back then. Monera included archaea and all the bacteria, all prokaryotes. And then eukaryotes would have been protista, plantae, fungi, and animalia. So they've since, using molecular systematics, which we're going to talk about in the next chapter, have further diversified the kingdom Monera into archaea and bacteria, because their cell wall is different, their modes of nutritional metabolism are different, and the time in which they have diverged from each other is so early, and they have been on such isolated evolutionary paths that they start to deem them different. All right, so now, instead of being in a 5-kingdom system like we were earlier, here, and here, we have now, systemists have started to break down the Monera kingdom into 2 domains, bacteria and archaea, and then you have the domain eukarya, which includes protista, plantae, fungi, and animalia. So that's the 3-domain system we're at right now. Except with all of the renewed interest in archaea, and which we're going to talk about in the next chapter, and all of the tools we have now in terms of molecular biology, it would be easy for us to say, okay, well, we can't just have 3 domains. That is so wide-ranging. And of course, you can further break down bacteria and archaea. So now they think, okay, there must be 3 kingdoms within bacteria, 3 kingdoms within archaea, 6 kingdoms within protista, and then the 3 kingdoms, plantae, fungi, and animalia. So now you're looking at, 6, 12, 13, 14, 15 kingdoms instead of going to 5, and then 3 domains. So we know that, taxonomy and classification is always going to be changing. And we just have to see, with all of the new species that we start to find and all of the new information we can, acquire, things are going to change eventually. And so taxonomy and the history of life is set, right? History doesn't ever change. But we're moving forward, we're starting to find more things in history that change the way we can think about biological diversity.